Hello everyone again. This is lecture 1 part 2 of current electricity. In the previous lecture we started with the introduction of current electricity. What was the difference between the charges put at rest and what is the difference between charges putting in motion. If the charges are in motion, then it constitutes an electric current, and that is the complete concept or initial foundation pillar of current electricity. Then we devised the initial concept generalized formula for electric current. Today we will move on to different concepts such as Ohm's law, etc. So, let us not waste any time. I am Sameer Lavankar. Let us begin our discussion. So, a course outline for you till now. Introduction is being understood in the previous part of this lecture only. Then we went on to electric current. In the electric current concept, we understood the generalized formula and the initial formula for I, which is equal to Q by T. If we generalize it into very instantaneous portions, then I is equal to limit delta t tending to 0 delta q upon delta t. Today we will go on to third concept here, that is electric current in conductors. So, let us move on, and after this we will move on to Ohm's law. So, electric current. So, this thing has been devised in your previous lecture only, that I is equal to small q by t, and if we need to generalize this concept, then it is I is equal to limit delta t tending to 0 delta q upon delta t. Please remember that the SI unit of current is amperes, and an ampere is typically of the order of magnitude of currents in domestic appliances. It may vary for lightning in around 10 to the power 4 to 10 to the power 6 amperes, and for the current which is involved in our nerves, in our muscular system, is of the order of 10 to the power minus 3 amperes. So, you can see the quite variation in the ranges of current used in different natural substances. So, let us move on with electric currents in conductors. So, what does it tell about here? So, an electric charge will experience a force if an electric field is applied. So, electric field concept you may have heard in your electric potential concept and capacitance, that there is something called as electric field. Let us suppose this is the electric field. Let me make the electric field like this. So, when electric charge if electric field is applied and there is a charge being kept here, then there is some force, it is under an influence of force. So, it is under an influence of force. So, this is a simple concept we just devised from the previous lectures of electric potential and electric charges. So, if it is free to move, it will thus move contributing to a current. So, this is the initial concept of introduction of current, that if a charge move either in an electric field or in no electric field, there will be a production of electric current. In nature, free charged particles do exist, like in upper state of atmosphere called the ionosphere. These are only and only applicable for lightning to occur. However, in atoms and molecules, the negatively charged electrons and the positively charged nuclei are bound to each other and thus are not free to move. So, this is one of the example of, so the upper stratus of the ionosphere has the ions which are of the free nature, and there are electrons, nuclei, protons, etc. in an atom which are of bound nature. So, these are differences in free charges and bound charges. This is an example of that. Okay. So, bulk matter is made up of many molecules. For example, a gram of water contains approximately 1022 molecules. These molecules are so closely packed that the electrons are no longer attached to individual nuclei. Hence, we understood in chemistry, we understand different types of let us say models such as Bohr model, etc., in which the proton and neutron are in nuclei and the electrons are moving in the final nature. There are different models for it, but it was understood that it is not bound with the protons and nuclei and neutrons. Electrons are free to move. They are not just bound such as comparable to protons and neutrons. So, these molecules are so closely packed that the electrons are no longer attached to individual nuclei. In some materials, the electrons will still be bound, that is, they will not accelerate even if an electric field is applied. So, there are some materials, even some materials in which the electrons will still be bound, that is, they will not accelerate even an electric field is applied. In other materials, so these material definitions refers to the fact that we have different types of materials such as conductors, insulators and semiconductors. So, depending on if the electrons are bound, depending on if it changes its positions, depending on if it goes into free nature or not, on the application of electric field or not, changes it into different concepts or derived into different concepts such as conductors, insulators and semiconductors. Okay. So, in other materials, notably metals. So, what happens in metals? Some of the electrons are practically free to move. So, because of the property of metals such that the electrons inside them are free to move, that is why they constitute an electric current very quickly, and thus due to this they are called as a concept or a word called as conductors. So, in other materials, notably metals, some of the electrons are practically free to move within the bulk material. So, let us say this is the complete steel table I am talking about, then because these are free to move, hence they constitute or called as they are called as conductors. So, these materials generally called as conductors. So, this is a definition we talked about here. Develop electric current in them when an electric field is applied. So, quite evident, when an electric field will be applied, the charges are, as they are free to move, they will move very freely from one point to another point. What is happening here, we will try to understand in subsequent slides, but for now we from this complete slide, what we understood is everything is either bound or a free in nature. If they are free in nature, then it is quite easy to make an electric current being produced in that complete substance. So, then there are divisions being talked about here, and the only division or the only material in which these molecules are free to move or they are not bounded leads to devices or leads to materials called as conductors. So, this was a complete explanation in this part. Let me move on to next concept now. Next, if we consider solid conductors, then of course the atoms are tightly bound to each other, so that the current is carried by negatively charged electrons. So, again we understood one of the concept that the charges which carry the current or which are helpful for the passage of movement from point A to point B is only due to negative electrons, negatively charged particles, they are called as electrons, and these charges constitute an electric current. So, if an electric current is being produced, or let us say we feel electric current in a conductor, those are due to negatively charged particles. There are however other types of conductors like electrolytic solutions where positive and negative charges both can move. So, an example of this electrolytic solution will be explained to you in subsequent slides, but for now just please understand this explanation again. So, in conductors what was happening, in solid conductors what was happening is there was a movement of charges from point A to point B under an electric field which leads to an electric current. Here the current is being produced by only negatively charged particles. Another example is being explained in the next point, in which it is said that an electrolytic solution also produces current, but this time the current is being produced due to the movement of both a positive charge also and a negative charge also. So, this is the explanation which is done in second point. Now, here we will focus only on solid conductors, so that the current is carried by the negatively charged electrons in the background of fixed positive ions. So, our complete theory, our complete concept which only will be talked about, the production of current will only happen due to the passage of electric or negatively charged particles from point A to point B. So, just let me write it here. So, first of all, solid conductors will be dealt very nicely, and here the assumption, first assumption is the current is produced. Let me write it. Due to the movement of negatively charged electrons. Let me write here negatively charged electrons, negatively charged electrons. And second concept is that we are assuming that the positively charged particles or positively charged ions are fixed. So, let me write positively charged ions are fixed. Okay. So, this is one of the assumptions which we will go through in the subsequent 2-3 points. So, consider first the case when no electric field is present. So, first of all let me assume let me move on with the discussion in which no electric field is present. The electrons will be moving due to the thermal motion during which they collide with the fixed ions. So, let us suppose these are the fixed ions, let us say this is the electrons and these are moving. So, these can move in either direction, it can either move in this portion, they can move this portion, they can move like this, they can move like this, anything can happen. So, the electrons will be moving due to the thermal motion during which they collide with the fixed ion. So, they can collide with the fixed ions. Let us suppose we are assuming this to be a fixed ion here. An electron colliding with an ion emerges with the same speed as before the collision. So, we are assuming that there is no plastic deformation occurring, hence the complete energy is being converted from point A to point B. Therefore, as the other charge is being fixed, therefore, the amount of charge with which the velocity with which it hits the positive ion, it reverts back with the same velocity only, but the direction may vary. An electron colliding with an ion emerges with the same speed as before the collision. However, the direction of its velocity after the collision is completely random. So, what does it try to say? Let me try to devise something here. So, let us suppose this is the positive charge. And this is the negative charge here. So, what does it try to say is, let us suppose that this was the direction of movement of, let us suppose this was the direction of movement of charge through which it hits the positive ion. Please make sure here the positive ion is being fixed. Now, what does it try to say is, let the velocity be v, then it says that after collision the velocity of the electron in the revert back direction will be same before collision and after collision. Therefore, but only the direction may vary. So, what does it try to say is, let me try to explain. So, the electrons can either go in this direction, it can either revert back in the same direction, it can either go in this direction, it can either go in this direction. But even if it goes in either of direction, the velocity will be same. So, this is the explanation, and mass will also be same, quite evident the mass will also be same, hence this is the complete concept. As we are not going into the mass concept here for the charges, the velocity will be same for the electric charge here, the electron here. Okay. So, at a given time there is no preferential direction for the velocities of the electrons, quite evident there is no preferential direction for the velocity of electron, it can go in any random direction. Thus, on the average the number of electrons travelling in any direction will be equal to the number of electrons travelling in the opposite direction. Thus, if we take a complete bunch, then at that time on average if you try to take every electron into picture, then what it was devised that the amount of electrons in travelling in any direction will be equal to the number of electrons travelling in opposite direction, hence the complete movement or the velocity component is 0. So, there will be no net electric current. Why? Let us suppose for one case, we are taking only an xy plot. So, what does it try to say is, let us suppose we are only assuming in our case that there are only movement due to or current being produced due to negative charges from point A to point B. Here what does it try to say is, let us say we are taking a case of delta t scenario in which after delta time t we are trying to find out the amount of charges being passing from point A to point B. Let us suppose this is the cross section through which we are passing. Here what does it try to say is, because on average the amount of electrons which is passing in this direction is equal to the amount of electrons which is passing in this direction, what happens after delta t is, let us suppose for our case I am taking that there were 5 electrons which has been moved from point A to point B. Because the 5 electrons from point B to point B were also moving, so hence there is the complete charge movement was 0, as delta q was 0 in delta t time, therefore, the current I produced is equal to 0. Hence, this is derived that there will be no net electric current only and only when we are taking the case when there is no electric field present. So, this is another thing which we defined. Now, let us move on to our further concepts. What will happen when there is electric field present? So, let us move on to that case now. Let us now see what happens to such a piece of conductor if an electric field is applied. So, if an electric field is applied, to focus our thoughts, imagine the conductor in the shape of a cylinder of radius r. So, now we are assuming, we are trying to derive everything with a mathematical formulation maybe. So, we are assuming that let us say this be the conductor, let me write it here. with a if the radius, yeah, so radius is given to you, that means this distance is given to you as r. Suppose we now take two thin circular disc of a dielectric of the same radius and put positive charge plus q distributed over one disc and similarly minus q at the other disc. So, what does it try to say is, we are taking two circular discs these are two circular discs being talked about here, and it has some dielectric. Dielectric means it has an efficiency or affinity to capture the charges and being intact in them. So, we are assuming or we are putting all the, let us suppose, positive charges in one sequence here and all the negative charges in one sequence here. So, these are discs being talked about here. Let me iterate it again. Suppose we now take two thin circular discs of a dielectric of the same radius. So, yes, please remember that the radius of both are same, which is equal to r. And put positive charge plus q distributed over one disc. So, positive charge are being distributed here and negative charge are being distributed here and negative charges are being distributed here. Now, we attach, so this thing is also explained. So, now we attach the two discs on the two flat surfaces of the cylinder. So, now what is being done is, we just took this disc, we put one disc on this portion as you can see and another point or another disc in this portion here. So, this is the thing being done. After this, an electric field will be created and is directed from the positive towards the negative. So, due to this dielectric discs being kept across a conductor, what happened was an electric field was created and is directed from the positive towards the negative charge. So, what was happening is an electric field was being what we can say produced here or created here, which was in distance. So, this is the electric field being constructed, but here just to derive it we assumed it as this portion as E. What does it, what the direction says, it is from positive or negative direction. So, an electric field will be created and is directed from the positive direction towards the negative direction, from the positive towards the negative charge. The electrons will be accelerated due to this field towards plus q. So, because the charges are being moved from plus to negative, the electrons will be moving from negative to positive direction. So, please remember this, even the electric field is moving in this direction, the electrons will move in opposite direction. It will get charged towards the plus sign, because opposite directions attract each other, therefore, the electrons will move from this portion to this portion. So, let me stop it here only. I will keep the explanation part of this in the next lecture. Till now I explained to you the complete model. What is happening is, till this point only the dielectric discs were being kept. Due to the dielectric discs being kept, the electric charges or an electric field was being produced in this direction, pointing from positive direction to negative direction, and due to that the electrons are being moved from let us say right disc, that is the dielectric disc with negative charges, towards the positive charge discs. So, now what will happen, what will be the current produced, what will be the current devised, etc. I will try to explain it in the next class. So, let me stop it here only. Thank you.